Now we have some idea of the second law of thermodynamics in terms of the heat engine and the heat pump. The most important point is that we cannot create the engine that gives us the absolute efficiency or the absolute COP, in the sense that for the heat engine we cannot have the engine with the efficiency equal to 1, because we need to leave some heat from the engine to the cold reservoir or the cold region. In the heat pump, we cannot have the heat pump with the COP approach infinity, because we must input some finite work W to the heat pump to transfer the heat from the cold region to the hot region. So what should be the next question is that, okay, we cannot make the ideal engine that gives us the ultimate efficiency. So what is the maximum efficiency of the engine that we can have? That can be answered when we study the Carnot cycle in the next section. But before that, we need to understand some concept of the reversible and irreversible process. This is very important in the study of the thermodynamics, because for the ideal, most of the ideal case, we will study the process that is reversible process. Okay. In the reversible process, it means that during the process, the system is in the thermal equilibrium all the time. And since the system is in thermal equilibrium all the time, it means that we can specify the pressure, the volume, and the temperature of the system all the time. And it means that we can draw like a PV diagram of the process all the time. The reversible process can be created by doing the change of the system very slowly. For example, here, if we have a piston and inside the cylinder is a gas, and above we put some sand above the piston. If we take away the sand, very small amount of the sand, it means that we reduce the pressure on the piston and the gas will expand. But if the amount of the sand is small, if we can just put 1 grain of the sand out of the piston, it means that the pressure change is very small. So the system can adjust itself to the new equilibrium during the process. So the important point of the reversible process is that it takes very long time, or it happens very slowly, to make sure that the system can approach the equilibrium condition, or can go to the equilibrium all the time. And from that we can specify the value of the pressure, of the volume, and the temperature all the time. The opposite to the reversible process is the irreversible process. This figure shows the example of the irreversible process. That is, we have the cylinder, we have the piston here, and we have the gas inside the thin membrane, and above this is the vacuum. Now somehow if we break this membrane, the gas will diffuse to the vacuum rapidly. Gas will diffuse to the vacuum rapidly. During the diffusion, the system is not in equilibrium, so we cannot define the pressure. It has to define the volume of the gas, because in some region the gas is still at a high concentration, but above this gas is a low concentration, and we cannot know how far that the gas reach in the vacuum. So it has to define the volume. The temperature is also hard to define. If you look at the temperature here, it may not equal to the temperature here in the vacuum. So we cannot define the pressure, the volume, and the temperature all the time until the gas go to the equilibrium condition again. But during the process, we cannot define P, V, and T. So this is an irreversible process. We cannot make the gas go back to this region and make the above region at the vacuum and insert the membrane. We cannot do that. We can break the membrane and make the gas diffuse, but we cannot say that the gas go back to its original place and insert the membrane in between and make the above the membrane vacuum and the gas under the membrane. So this is an irreversible process. We cannot draw the diagram like this during the diffusion of the gas in the irreversible process. So if we want to analyze the process, at least not so complicated, we will look at the reversible process. However, you can see that the reversible process is quite an ideal process, because it takes very long time to expand the gas. So it is always in the ideal case that we look at the reversible process. Most of the real process, the process in the real world, is an irreversible process. So we can say that all real processes are irreversible. The reversible process is an idealization. All real processes on the earth are irreversible. But study the reversible process is easier. So to understand at least the qualitatively of the process in the real world, we will look at the model. As we look at the model of the motion, ignore the resistance of the air, ignore the variation of the gravitational acceleration. Here also, if we want to look at the model of the process, we will look at the reversible process to understand at least qualitatively the description of the process.